Thank you very much. And yes, I have a few slides that I ask the moderator to pull up. In the meantime, I will just mention how deeply honored I am to address this meeting today. I'm thankful for the invitation. I am, of course, a civilian, so I will start my presentation from a civilian perspective. And I'm very glad that the concept of public-private partnership was just brought up, because that's an integral part of my presentation. If we can move to the next slide, I would just recall that from a civilian perspective, we reason in a very different way than the military approach. From a civilian perspective, companies undergo a risk evaluation. And the risk is composed of three big variables. It's not a multiplication, but it's a composition of three variables. The existence of assets of value to the companies, the presence of vulnerabilities, and their exploitability and their ease of exploitation, and the existence of threats. So as many of the speakers before me have introduced, the existence of threats at a global level is actually very significant. But from the point of view of a company, there is an enormous issue in securing critical systems. And the issue is that in the analysis of risk, whenever we have enormous potential of damage and a very limited probability of happening that are already hard to estimate, the more these two things diverge, the more the assessment of risk is difficult. And this is something that, in effect, that is sometimes termed the black swan effect. Unfortunately, this was made very famous by the writing of Mr. Taleb, that are not exactly the right approach for cybersecurity. But even in cybersecurity, these type of risks are a black swan. They can, if they happen, they will have existential damage. And in the next slide, I would like to mention the fact that the existence of critical assets that are either in public hands, but in the hands of public companies, or more often in private hands, is ubiquitous. Most of the critical infrastructure of our society is either private or operated under private laws. And this means that, for instance, the electrical distribution is, yes, most of the companies that doing electrical distributions are the remnants of public companies, but they are now in the private market. Most of the companies offering the internet services are in the private market. Just think about Amazon, for instance. Amazon hosts about 15% of the worldwide IP address space. The address space of Amazon is larger than the address space of many nations. So these infrastructures, these critical infrastructures are there, and the need for protecting them has been recognized by the governments and the political entities for a very long time. Here I have the remarks from Viviane Reding, who was the Vice President of the European Commission 3 commissions ago. So we have been looking at this at a societal level for a very long time and trying to figure out how to deal with this at the societal level. And the reason why I am focusing on private companies is exactly that. One, the private companies in most cases own critical assets that in any event of warfare, for instance, or aggression in general, or terrorism, would be a target of attack. And on the next slide, very often these strategic elements, both in the military and in the non-military world, get hit by even accidental catastrophes. If you just Google up for aggressions of ransomware or malware that created an issue, within the military of the civilian world, you will find several instances. Many hospitals in the UK were hit by WannaCry, which was, shall we say, very simple, very effective, but very simple piece of malware. Hospitals are a critical infrastructure. And they are also, in the case of the UK, they are government run, so they are not a civilian-owned infrastructure. But you get my drill. There's at the level of threats, many of our critical infrastructures are vulnerable even to quasi-accidental attacks. On the next slide, I would also focus on the fact that for many companies, what they focus on are financially motivated attackers. For instance, Norsk Hydro was hit by a very significant financially motivated attack. And the reason why I'm citing them is not because I want to hit on them. Actually, I want to commend them. They were very public in their response to the attack. They were very public in detailing how the attack was carried out. They presented at security conferences, sharing lessons learned. And they did not yield to the attackers. They did not negotiate with the attackers. They did basically everything that they could right in a very dangerous situation. So that's why they are on my slide here. But many companies have been hit by financially motivated attacks. And these are the attackers that companies prepare for. Because financially motivated attackers are easy to handle. Not really easy as in easy to get away from, but you can understand where they're gonna hit. You can change your security processes so that the attack costs to you more than it yields. Once the attack costs to the attacker more than it yields, the financially motivated attacker is going to go away. And this is within the budget of most large companies. Then, of course, there are failures. There are times when these defenses fail. But this is an approach that most companies can make. However, unfortunately, and relevant to this context, and on the next slide, we also have state-sponsored attacks against private companies. And here is the point where the mechanism breaks down and where all of the elements that, for instance, Professor Baldoni recalled before, come into play. Because private companies are at the forefront of the future battles in cyberspace. And there is a thing that I often remark, in particular when talking with a military audience. And it is that while NATO and the member countries, and also many other countries in the world actually, have taken a right choice in understanding that cyberspace is one of the areas of operation for the future and actually the current military. Calling it a domain of war actually carries an implication that I'm not completely sure is correct. The implication is that all of the other domains of war are physical topological spaces. You can establish dominance, you can establish a perimeter, which is actually such a common way of looking at things that it is also in the naming of things in our Italian legislation, and I think in legislation throughout Europe. Now, in cyberspace, it's very difficult to actually establish a perimeter. Cyberspace is not topologically connected. It's not true that to get to Italian cyberspace, you need to cross Swiss cyberspace if you're coming from German cyberspace. So these are unique properties that are, of course, already the target of evaluation of several interesting papers, for instance, from the NATO CCDCOE in Estonia, but from many institutes around the world, there are very interesting strategic papers about this. But this places companies in an uncomfortable position. The position of being on that hypothetical, not really existing perimeter. Every company needs to defend against state-sponsored attackers, against, for instance, terrorist groups, against hacktivists that, since cyberspace is an asymmetrical battlefield, may be just as effective as a team of special forces operators in another context. You cannot run a special forces operation out of your basement, but you can do that in cyberspace. And companies are not unprepared about this, but they cannot be prepared. Because in that equation, the amount of money needed to prepare against such attackers that are not financially motivated is outside any scope or budget that is significant for companies. And this is not something that is going to happen. This is something that has already happened. It has happened in Ukraine with the black energy malware in 2014 as part of an actual warfare operation. It has happened on NATO countries' critical infrastructure throughout 2017 due to an ICS, an industrial control system attack framework called Triton. If you have never read about it, I would suggest that you actually go and read the report that several cybersecurity companies in the private world made about this, Dragos, for instance, and others. Because that's an example of a framework structured for cyber warfare in all but the name that has been deployed against critical infrastructure around the world, in particular against Western critical infrastructure, Western countries' critical infrastructure. Or, if you want, the outstanding hack on Saudi Aramco that almost wiped out their non-industrial infrastructure. And that's just because attackers didn't want to wipe out the industrial infrastructure. Because with the level of access that they demonstrated, they probably could have pivoted in the industrial infrastructure pretty much in the same way that the attackers on Ukraine infrastructure pivoted from the corporate infrastructure of Ukraine's power operator to their industrial control systems, pretty much in the same way. That could have happened in Saudi Aramco. And that would have disrupted a significant source of the world's oil, with all of the strategic implication that the audience is way more able than me to understand and assess. On the next slide, I would like to move on to the vulnerability component of that analysis. Risk is made by value of the assets, existence of the threats, we have established those, existence of the vulnerability. Now, this is a picture taken from a search engine called Shodan. You can access it, it's public, shodan.io. Shodan allows people to search with a Google-like interface for things on the internet. So you can search for things that have a certain type of software or a certain type of hardware. Now, this is an image that they constructed. It's actually from a presentation they did a few years ago. So, but you have actually the rolling image on their website if you want to access it, of industrial control systems that are exposed to the internet. And I would like to point out that I didn't willingly put on the chart the NATO countries. But if you look at the chart, the infrastructure that is exposed is basically NATO member countries. This is an effect of our country's strong industrial basis and of our country's free access to the internet. Of course, you don't see China that much on this map. That's because there's the Great Firewall around it. Since we do not want that, we need to secure this. And on the next slide, the vulnerabilities of industrial control systems stem from the fact that the systems were designed to be not connected to the internet. They are designed to trust the network they are in. They are designed to operate as if everything on the network is trustworthy. And this means that when they get connected to the internet, either by chance or by will, because we are pushing those as private commercial companies, we are pushing those to be connected to the internet because that improves our productivity. It's the whole Industry 4.0 terminology that you may have heard from the European space mainly, because in the US this terminology is not used that much, that pushes these industrial control systems to be connected to company control systems and to the internet at large. But these are safety critical systems and critical infrastructures, which sometimes do not have humans in the middle. And in this case, the security of the systems protects environment, humans, critical infrastructure, all things that we as cybersecurity people, I am a cybersecurity professional. I've been doing cybersecurity all my life. I have no military background. We protect, usually, we used to protect data. We have shifted our mindset into, oh, we are protecting way more than data right now, just in the last few years. Let me give you an example from the civilian world. The next slide. This is an industrial robot, okay? And on the next slide, you can see how industrial robots are usually deployed in so-called protected spaces. If you open that cage, if a human opens that cage, those robots stop. There's a mechanical and electrical stop, and they stop. Whatever the computer is telling them, whatever an hypothetical attacker is telling them, they stop. They will never harm a human, because if a human enters the protected space, they stop. Physically, electronically, mechanically. But, next slide, these are future robots, cooperating with humans, close to humans, without a protected space. In this robot, it's from ABB, it's called the Yumi, and it's a beautiful robot, and it's super safe. I feel safe close to Yumi. We actually have the second prototype in the world of Yumi here upstairs, because we cooperated with ABB on research on Yumi. So Yumi is super safe. It will never harm a human. It cannot harm a human. But all the safeguards that make Yumi so safe are in its software. And so they can, if it's not properly protected, be sabotaged. That's a significant difference. And many industrial control systems are undergoing the same difference. They are super safe. They are super safe for the environment, for the humans around them, because the software makes them safe. That's a different word than where the system was safe because it was designed to be safe. This is in contrast, for instance, with aviation, where cybersecurity impacts are so diminished because aviation has so much redundant safety in non-digital systems that make it safe, even if an attacker were ever able to break into one of the systems on the aircraft. And the next slide, I just mentioned what we found in our industrial robot research result. We found old-style vulnerabilities, like vulnerabilities from the 90s. In 1997, I started my research work on cybersecurity outside of a research environment, shall we say. And those things were exactly the same as the ones that I found and exploited in 1997. Outdated coding practices, because the people building these things are automation engineers. They are best in the world at doing automation. They are not software engineers. We cannot require them to be. Are coded credential. Actually, in the manual of ABB robots, there is an uncoded credential that cannot be changed and that cannot be turned off. There's no encryption. There's no signing of software and updates. When your phone downloads an update, it checks that it's valid. Attackers cannot compromise it. Half-a-ton robots that can kill humans don't. So all of these results you can read, that we don't have time to go into them, but there is this website that we put up, robosec.org, with both managerial style and technical style and scientific style reports about the security of industrial control and industrial robots. So I get to my conclusions on the next slide. Critical infrastructure as protection as black swan characteristics. Assets are privately owned, but damage is societal and can be extreme. There's a variety of threats, and non-financially motivated threats can easily transcend the private cyber defense budget. So private ownership, private defense non-financially motivated attackers are a bad mix. That's where public-private partnerships come into play, necessarily. There's no way private companies can deal with state attackers without support. Vulnerabilities in the industrial systems and in critical infrastructures are not what you hear about, the 0 days, the new brand shiny new thing that comes out today. There are things that have come out in the past 40 years. We have an enormous technical depth there. And as a society, we are moving in the direction of increasing dependence of these cyber physical systems. So I thank you very much for your invitation. Next slide. I thank you for your attention. These are my contacts. I just take 1 second again to gratefully acknowledge that some of my past research on this has been supported by the NATO Science for Peace and Security program, and that support is gratefully acknowledged. Thank you.